bandsaw. This is a Jet 18-inch model. It's a woodworking bandsaw. Works fine, lasts a long time. Won't rust, bust, or collect dust. This machine right here is specifically for woodworking. It does not have variable speed. The speed is set. It goes about 3,000 RPMs. Way too fast for metal. Metal requires usually under about 300 RPM. This machine is called the bandsaw because the blade is basically a band of steel. As you can see, we have two large wheels, one on the top that spins free and the one on the bottom, which as you can see is belt driven off the motor. The band goes in a long oval down this way, down to the bottom wheel, comes around the top and goes back around again. When the machine's on and the motor's turning, it's moving like this at 3,000 RPM. The first thing that we're going to do is we're going to talk about some of the parts and pieces on the machine. First off is that we have this black knob here, which is the upper door lock knob. We have this hand crank here on the front. It is the upper guide crank. It raises and lowers the upper blade guide like this. We set the upper blade guide for the height of the material that will be going through the machine. Underneath here we have another hand crank that sets the blade tension. This is the upper blade guide. On the front over here you'll see that there is the on-off switch. You turn it on by pushing in on the green button. To turn it off, you just push on the red valve. This of course is the blade. Like the rest of the machines in this shop, we do have a table surface right here. Notice that my table has an orange rectangle that's been painted on, and that is the place where your fingers will not be when you're operating the saw. That's the place where your fingers will not be when you're cutting wood on this saw. On the back side over here, there's a dust port. Of course, if this is the upper door, then this must be the lower door. And we have a lower door lock knob. Very important safety consideration that these doors are closed if the machine is on. If you get tangled up in that wheel that's spinning around in there at 3,000 RPM, it's going to ruin your day. Okay, there's some steps that we're going to go through to ensure that we can operate this machine safely and effectively. Before we check the machine and prepare the machine to be used, before we check the material to be used, we're going to check ourselves and make sure that we're ready to work in the shop without being a hazard to ourselves or the people around us. You must wear eye protection, safety glasses when you operate this machine. Occasionally you may need to also wear hearing protection, although it's rare. It doesn't generate enough noise normally for us to need to wear hearing protection. If we're doing something noisy and we're going to be doing it for a while, like all period long, then we'll put on earmuffs also. Safety glasses protect your eyes from dust, they protect your eyes from flying pieces of wood, and they protect your eyes from blunt trauma. Young persons, are your everyday eyeglasses suitable for wearing? Will these substitute for safety glasses? No, they will not. I do not care if you order your everyday eyeglasses from some Swiss optics company and you can take 3 7.62 rounds in a row without penetrating the glass. You must put on safety glasses to work in the shop and to use this machine. Taking into consideration all of the machines that we have present in the wood shop, this is one of the safest to use. If you can manage to keep your fingers away from the spinning band of death right here, then it's very safe to use. Kickbacks and hazards of that sort just aren't a hazard on this machine. What the bandsaw is good for is cutting curved lines. If we're going to cut a straight line, we have machines that will do it better and more precisely. For it to be able to cut that curve efficiently, it greatly depends on which blade is installed. So the thinner the blade is this way, and the thinner the blade is this way, greatly affects its cutting performance. The wider the blade is this way is going to determine how tight of a radius that you can cut in your material. So there's a rough charts that you can find on the internet that say, a 3/8 blade will cut a circle with a 2.5 inch diameter, whatever. Your mileage may vary. So your thinner, narrower blades allow you to cut a curve of a much smaller radius, and thicker, wider blades are better for cutting relatively straight lines. So step 1, prepare yourself. Step number 2 is prepare the machine. Make sure it has the correct blade on it for what you're trying to do. Remember, your thinner, narrower blade is for cutting a tighter radius. We use a thicker, wider blade for cutting a larger radius. You're going to want to check the material. The first thing on the material I'm going to tell you is that one side of the material must be flat and straight to be used on this machine, so that when you sit it on the table, it sits there without rocking. One thing we will not do ever is cut round stock on this machine. We could probably build a special jig or something if it's what we really needed to do for some reason, but we're not. You're not cut round stock on this machine in this shop. You'll notice that in this shop, most of the machines have an orange zone painted where your fingers are not allowed to be while the machine is running, and the bandsaw is no different. In step 4, we're talking about using the machine correctly. Number 1, there is an orange zone here, or an orange rectangle. Do not allow your fingers to be in this area when you're using the machine. For example, if you're cutting something very small, even though the machine can handle it, you will not probably be able to do this in here because it will require your fingers to be in the orange zone, and that's unacceptable. When you're cutting something on the machine and something goes wrong where the material starts to bind and it's just not working very well, do not try to back the material out of the cut. You must turn the machine off and wait for the machine to come to a complete stop, and then remove the material from the blade. As you're using the machine and small pieces of your cut begin to build up around the blade, do not try to remove them with the blade moving. Always be aware of the blade. Those pieces, if you're going to try to remove them, use a separate stick to push the material off the table. Okay, step number 5 is deal with the unexpected. When you're using the machine and you all of a sudden hear a clicking noise while the machine is running, then you're going to want to turn the machine off immediately. I've never seen it or heard it myself, but if the blade were to get a crack in it that was starting to work, and it will make a clicking noise as it's going around in the cabinet. So we're going to shut the machine off, and you're going to call me over and we're going to figure out what needs to be done. Dealing with the unexpected, once again, you're going to want to avoid distractions, and please avoid being the distraction. If you are using this machine and some person comes up to you, taps you on the shoulder, or tries to get your attention, they are not your friend. You need to ignore them, finish what you're doing, wait till the machine comes to a complete stop after you've turned it off, and then deal with the distraction. This machine is very safe to use. You don't have to worry about getting a kickback. The material will just sit there with the blade running, and it's not going to go anywhere. However, you must avoid putting your fingers into the blade. If this machine will slice right through a 2x4, it's going to slice through your finger like butter. So one of the ways that we're going to make sure we keep our finger out of the blade was keep your fingers out of the orange zone. And if someone tries to distract you, you're going to ignore them, finish what you're doing, and then deal with that distraction. Step number 6, very important. Please, use common sense. If you're doing something on this machine and it just doesn't seem right, it doesn't feel right, it doesn't sound right, if you're not comfortable running the machine, then stop. Back up. Wait, watch another student use the machine, or call me over and I will demonstrate the machine to you again. We'll talk about exactly what you're going to do and how it's going to get accomplished. I don't want you to do something in here on this machine or any other machine in this shop if you don't feel comfortable, if you're not confident of what you're doing, if you're not confident of what's going to happen next. What are your questions?
This is the drill press. Now the drill press is really a pretty simple machine. Use it for drilling holes, as you might suspect. Let's talk about the mechanics of the drill press first, and then we'll show you a little bit of what it can do. At the back here, you've got a motor that is suspended from the back of the assembly, and that's attached to a series of pulleys. And the pulleys, of course, are connected by belts. And by changing the arrangement of the belts on the pulleys, you can change the speed of your drill bit. This one has, as most do, has a very nice handy chart inside to show you which arrangement of belts and pulleys gives you what speed. And this one goes from about 340 RPM up to 2800 RPM. Down here is the chuck. This should look familiar if you've ever seen a handheld drill. This is the part that holds the actual bit, and like some of the handheld drills, this one opens with a key. Insert the drill bit, snug it up, and it's ready to go. Some models also offer keyless chucks where you can just tighten them with a twist of your hands. This assembly raises and lowers the drill bit, raises and lowers what's at this whole assembly is called the quill. So you've got that travel, so you can drive the bit straight down into your work. And then on the left side here, there's a column, and this one has a screw type stop on it. You dial these down to the specific depth, and now when you go, your travel is limited, so you can drill a hole of a limited depth. That's called a counter bore. So if you don't want to drill all the way through a piece, this stops the bit before it gets through. This particular model is a floor type drill press, a floor standing drill press. That's pretty obvious where that name comes from. It sits on the floor. The other type that is available is a benchtop drill press. It would typically have a foot at about this level, and you would set that on top of a bench for work. A benchtop drill press might be the best place for you to get into a drill press if you're doing woodworking. The floor standing model offers a whole lot more capacity to get the table down, so you can get a larger workpiece between the table and the bit. But for most of the jobs you're going to do in woodworking, a benchtop drill press will cover you, and they're a little less expensive. On most drill presses, you'll see a geared assembly like this. A handle. Spin the handle, and you can set the table at whatever height you want, and then tighten the handle to lock it in place. Tables will also pivot, so you can just move it out of the way if needed, and you can tilt it. Raise this back up to where I can get to it. By loosening a bolt down here, you can then pivot the table, and there's a gauge here to show you how much your tilt is. And there's one final control down here, pinches the table in place so you can rotate it if that's needed. Now, a table does an awful lot, but frankly, this is one of the shortcomings of the drill press, because this works fine for metalworking, which is where the drill press originated. But if you want to improve your drill press for woodworking, one of the best things you can do is add a table. This is one that was featured in Wood Magazine. Drill press table offers several advantages. Number one, you've got this much larger work surface so that you can more easily support larger work pieces like you would have when you're building a cabinet or something. I think one of the best features is that you have the opportunity for this to add this fence here that you can clamp in position and move work pieces along. Now you can drill holes that are consistently spaced from the edge of a workpiece. You can drill here and here and here. Also gives you a better margin of safety. As you're working, if the bit should catch in a piece, it's not going to spin because it's pressed up against the fence. This one also offers extendable wings. You can clamp stop blocks here so you can move a piece out and always drill holes in the same place on multiple work pieces. When you're using a drill press, really very simple. I've got this piece that I'm going to Say this is the side of a cabinet. I've got shelf pins measured out, specific distance. I'm going to position these under the drill press. My first mark, oops, that looks like a bit of a problem. My handle is hitting my fence. But that's really not, because these handles are designed to unscrew for that very reason. Just set that one aside, and now I have my travel that I need. So I'm on my first mark, position the fence and lock it down. Now I can start drilling holes. Since I don't want these holes to go all the way through, I'm going to use my stop over here to make them just 1/4 of an inch deep. And just to show you how deep that's going to go, that's how deep the drill bit will be when it hits the stop. So all my holes will be of consistent depth. So you can see how I can keep moving down the line and drilling holes. Let's say I did want to drill through holes here. I'll just take my stop up so it's out of play. I don't want to drill through and drill into my table, so take a piece of scrap, put it underneath there. Now when I drill through, I'm drilling into the scrap and not my table. The other thing that backer board does for you is it gives you a nice clean back on your holes. Let me show you another neat trick that your drill press can do. This is a drum sander. You can take this and put it in place of a drill bit and turn your drill press into a drum sander for sanding curves. If I've got a project where I have a cutout like this, you can see where my pencil line is. I've rough cut that on the scroll saw. And then I need to sand up to this line. Well, doing that by hand would be very tedious and probably not really exact. With a drum sander in the drill press, turn this on. Okay, I'm getting very close to my layout lines there. I like to be able to freehand this so I can use the full surface of the sanding drum like this, but once I get close to the edge, I want to make sure my edge here is 90 degrees to this face. So to accomplish that, I'm going to clamp a scrap just in front of the sanding drum here. Slip my workpiece in. And raise the table so it just catches the drum. Now, I can finish up resting this on the piece here, and I'll end up with a surface that is 90 degrees to the face. I only want to do this for the end, but again, the one drawback is I'm using just a portion of the sanding drum here, but this will give me a nice square surface. One of the strengths of the drill press is you can use bits you wouldn't want to use in a handheld drill. This is a wing cutter. It spins around here and cuts perfect circles, and you can cut rather sizable circles by adjusting this arm in and out. In a case like this, I've got a piece that I can't use the fence. The piece extends too far back, so I can't use the fence to brace it against. I want to make sure this piece stays put, and with this thing spinning around, I really don't want my hands anywhere near this. So I need to clamp the piece in place. I've got a backer board between my table and the workpiece. So when the bit pokes through, it won't tear up my drill press table. Clamp the workpiece in place, make sure the table's locked in place, and we're ready to go. A wing cutter should run at very slow speeds. So there we have a perfectly circular opening, and if perhaps you're making wheels for a toy project, you've also got perfectly circular cutouts. There is another type of large bit that drill presses handle quite easily. They also cut circles. They are not as adjustable as the wing cutters. In fact, they're not adjustable at all. They are at fixed diameters. These are called hole saws. If you take a look at the teeth on that, you can see why they're called hole saws. It's just like a series of saw teeth around the perimeter with a drill bit in the middle to guide. Now those aggressive teeth on a hole saw, here again, those teeth can grab hold of the piece and spin it around if it's not clamped down. So you want to clamp your workpiece securely in place so it doesn't come spinning back on you. Also a bit you run at slow speed. When you compare a drill press to the alternative, which is probably a handheld drill, there really is no comparison.
Hello everyone, I'm Mike and welcome to my DIY workshop. This video shows you how to hammer nails effectively, and there's another video that goes with it called Extracting Nails Safely. One of the things that has given me extra satisfaction when doing my DIY jobs over the years is to complete the project using whatever materials I've got available, including fixings like nails. So I'll be showing you one or two tricks to use nails that aren't quite the right length. And now a look at the hammer action. Bear in mind that it is the weight of the hammer head and its speed that drives the nail. Your job is to control that speed and direct the hammer head exactly on the nail like that. Hold the hammer shaft at the bottom or a bit further up if that's more comfortable for you. Tuck your elbow into your side and flex your wrist. That's the main hammer action and will give you good hammering power for small to medium sized nails. And now a look at DIY nails in common use. These are round wire nails and oval nails. These will do much the same job as these, except that these have a bigger head, and so they're more useful for rough sawn work where strength is more important than finished appearance. These, on the other hand, will do much the same job as those, except that the head can be punched into the wood and it will be less obvious. It can also be punched further into the wood and the hole filled up and painted over, so that could be important for internal joinery work that you're going to paint. Finally, for slender wooden mouldings where strength is not an issue, you just want to hold them in place, you can use these rather slender panel pins or even thinner moulding pins, and you can either knock them in flush and still see the little nail head, or punch it in, fill the hole and decorate. Right, let's drive a few nails. There's a very slender nail, not much effort required to knock it in. Just hold it in position while you tap with the hammer. As soon as you can let go and the nail stays put, you can just give it a few whacks and it's in. That one's a bit fatter and a bit longer. Hold it in place, tap it with a hammer, take your hand away. By the way, if you come across a nail like that, it looks as though it's got a screw thread on. It's intended to make the nail far more secure, so when you've knocked it in, all those little rings grip the wood and it makes it very much harder to pull out. It's called an annular ring nail. A much bigger nail, much stiffer, much less likely to bend while you're hitting it, but it takes more hitting to drive it all the way in. Here's a difficult situation. A lot of softwood has knots in it, and I strongly advise try to avoid knocking a nail through a knot. You're more likely to be able to drive one of those through, but it will, if the knot is really hard and deep, it will take a lot more effort to drive the nail. So if at all possible, nail at the side of a knot. And if the second piece of wood you're nailing to has a knot in it, you might like to drill a hole about half the diameter of the nail to make sure the nail will go in easily in the direction you want without too much effort. By the way, I wouldn't advise trying to nail MDF unless it's a very temporary job. I'll just show you. It's easy enough to nail. But there you are, it's split, and it's split there as well, and also because of that I can pull it apart as easy as that. MDF is okay if you want to nail it that way, because you as long as you keep the nails away from the edge. Now here's a useful tip. If you're driving nails, particularly oval nails with their smaller head, and you get the impression that the hammer is skidding off the head, here's a tip. Take an old bit of sandpaper, rub the head around on the sandpaper to make it nice and bright, and that will give you a much better grippy surface to make good contact with nails. Let's just think about suitable nail lengths. In that situation, 2 pieces of wood. That nail, I would suggest, is slightly too long because it could just come through here and be a sharp hazard. You could file it down like that if it's only a tiny bit protruding. Alternatively, and this is better, if you think about it before you drive the nail, drive it skew-iffy like that so that the point is not going to come through the face here. Here's another situation with much thicker pieces of wood. There's a nail that's probably just about okay. It could be slightly longer, but in this situation the nail is positively too long, and it's a case of you can't just skew it like that, because you'd have to skew it an awful lot to lose the length of the nail. So another possibility is to clench the end of the nail if finished appearance isn't too important compared with strength. So I'll just drive that nail in and then show you how to clench it. So here I've driven the nail right through, so now I'm going to show you how to flatten it down to make it safe and make the joint strong. We need another heavy hammer like this lump hammer. Now I'm going to hit that nail sideways, and I'm doing it in the direction of the grain. You could do it that way, but it'll be harder to hit it right flush into the wood. This way it'll go into the wood nice and flush very easily. So there you are, that's clenching the nail, and that is very strong because that will be very, very hard to pull that off because that's turned over. And now I want to demonstrate shortening the nail. You could be doing a simple repairing job where you just need a couple of nails a bit shorter than what you've got in stock. You don't want to go down to the shops, and this is how to do it. Just simply take a pair of cutting pliers and cut the nail on the skew like that. So that's got a good enough point on to drive it in. This one, similar fashion, takes a lot more effort with the cutting pliers, or you could do it with a hacksaw, and that's the finished result. But it's a good way of getting you out of trouble quickly when you just simply want a couple of short nails to finish the job. What I want to show you now is how to overcome bounce. Now, this problem could be in a typical situation with fencing, where this is a long fencing rail and this is a fencing upright which you want to nail to the rail. Normally, if you try and nail, the whole thing bounces and all the hammering power is lost in the bounce. The trick is to get something heavy like a brick, hold it in place, or get somebody else to help you. But you can see that the brick helps to stop the bounce. I've got one more tip that I want to show you. Here's a very small panel pin which is very difficult to get started, even if I use a tacking hammer like that. The trouble is I'm hitting my fingers at the same time as hitting the nail, and it's very uncomfortable. So a better idea is to use a pair of thin-nosed pliers, put the tack in place, give it a whack, take the pliers away, and there you are. Using this as a model, I want to show you punching the tack in so that you can fill the hole and decorate. So what you need is a suitable sized nail punch. That's the one I'm going to use, that's for bigger nails. So what you do is carefully position the punch exactly on the nail head, press down hard and a couple of taps, and that's sunk in enough to fill the hole. I've got one final thought for you. When you do nailing, you make a lot of noise and cause a lot of vibration and even dust. An alternative, of course, is the good old faithful wood screw, which is so easy to use with modern power drivers. An alternative to that even is modern day mastic gun adhesive, because you get instant grab, it's silent and so quick. The icon for my second video on extracting nails is coming up on screen now. Click the icon if you would like to watch it now. If you would like to subscribe to my channel, you can click on the circular avatar down on the left down there. Thank you for watching, and I hope you'll join us again very soon.
When it comes to clamping, Irwin quick grips really are best in class. Really well thought out. So what you've got here, you've got a 12-inch capacity clamp. Just pull the lever there, you've got instant slide, and you've got fine adjustment on the trigger there. Slide it up, you've got a rotating on a cam pad there, which is a really useful feature if you're clamping anything that's slightly askew or uneven. This moderates and adapts to give you a nice, strong, firm clamp. If you don't want that, put it up, slide this across, and it doesn't move anymore. It's locked in place. These clamp up to 135 kilograms of force, so they're really, really strong. And the nice thing about these clamps is clever stuff in here. It's an anti-burst mechanism. Some clamps, when you release them, they explode. Not the quick grip, simple as that. How's that? Another nice feature on these, as well as clamping, undo the end here, slide it off, put it on the other end. You've got not going to lose that because it's a thumb turn on a spring. self-locating, that's there nice and firm, and what you've got, instead of a clamper, you've got a spreader. So it's ideal for two jobs. If you need to pry something apart to re-glue it, and we're going to see that in a second, or clamping for gluing applications. Holding workpieces when you're working, you need one hand free. These are the things to use. This one has got a 12-inch capacity, which is 30 centimetres, and let's see an application for it. We need to re-glue the bottom, we need to split the top out, so gently, that's coming out. We can put that back, and then we're going to re-glue the bottom and clamp it up. So there's the spreading application, nice and controlled. So there we go, we're all glued back in there. Just final squeeze to hold it in, hold it securely while the glue goes off. 12-inch capacity, 30 centimetres, most popular size. That'll be done and set overnight, then we can take it off. Most tradesmen will have several of these on the van because they're so useful. It's such a useful tool to have in your toolkit. The Irwin Quick Grip clamp with the soft rubber non-marking pads. Super product from Irwin.
There is no more basic wood joinery than the butt joint. A butt joint is nothing more than when one piece of wood butts into another, most often at a right angle or square to another board, and is fastened using mechanical fasteners. This type of joint is often used in wall framing on construction sites. A mitered butt joint is nearly the same as a basic butt joint, except that the two boards are joined at an angle instead of square to one another. The advantage is the mitered joint will not show any end grain and is more aesthetically pleasing. However, the mitered butt joint isn't all that strong. A pocket hole involves cutting a slot and pre-drilling a pilot hole at an angle between two boards before connecting the two with a screw. This pre-drilling needs to be very accurate, so it's typically accomplished by using a jig. Pocket joints work great for cabinet face frames and other similar applications where a lot of strength is not needed. A dado is nothing more than a square groove slot on one board where another board will fit. Similar to tongue and groove joinery, this is a commonly used wood joint for connecting plywood, such as building cabinetry. Another common wood joint used in cabinetry is the rabbet. A rabbet is essentially a dado cut along the edge of a board. Rabbets are often used at the back of cabinets and other similar assemblies for attaching the back to the sides of the box, adding a considerable amount of strength to the assembly. A sliding dovetail is a versatile joint with a lot of possible uses. A good way to think of it is as a locking dado. The half-lap joint is where half of each of the two boards being joined is removed, so that the two boards being joined together flush with one another. This type of wood joint can obviously weaken the strength of the two adjoining boards, but also is a stronger joint than butt joints. There are a number of projects where this type of wood joint is quite desirable in spite of its drawbacks. Of all wood joinery methods, the through dovetail may be the most revered. A classic through dovetail is beautiful and very strong and adds a touch of class to any piece. There are a few methods for creating through dovetails, from hand cutting to machining with a jig. There are situations where a dovetail joint is the connection of choice, but both edges of the dovetail should not be visible. A perfect example is a drawer front, where you don't want to see the end of the through dovetail on the face of the drawer. For this type of joint, the best choice is a half-blind dovetail. Dovetail joints are beautiful and strong, but not always practical. A box joint is a simpler alternative to dovetail joints. A mortise and tenon is a classic wood joinery method. These joints have been used since the early times of woodworking and are still among the strongest and most elegant methods for joining wood. When joining two boards square to one another along a long edge, one can simply butt the joint together and hold it with fasteners. However, the tongue and groove joint is much stronger and provides more adjoining surface areas, which is particularly useful if you are going to glue the joint. Another method for joining boards along the edges, like the tongue and groove joint, is to cut slots and use beech wood wafers known as a biscuit to hold the boards in place. This is a very useful modern woodworking joint, particularly for creating tabletops relying on glue and the swelling of the beechwood biscuit to hold the boards in place.
Hello everyone, I'm Joshua Clement and this is Steps to Sand and Varnish Your Wood. Sanding your wood is a very important step. It'll make sure that you have a very nice end product. For this job, you will need some sandpaper. I like to use 220 grit. You will also need some varnish, a paintbrush, made sure that it's used for stain, and a sponge or a rag. When you're sanding your wood, you don't want to concentrate on the corners only. You can hit the corners a little bit, but if you do too much, it's going to end up leaving some different divots in your wood that don't look natural. You also don't want to sand in one spot too hard because that's going to leave a divot in your wood. It's going to soak up a little bit more varnish and make it look funny. So you want to do nice, even strokes. You don't want to go against the grain. You want to go with the grain. If you go against it, it's going to end up breaking those fibers in the wood and making too much stain soak in there. So you'll start around the middle of the board and work your way to the edges. When you hit the edge of the wood, you don't want to press real hard. You just want to smooth that out a little bit and get rid of any burrs that are on there. After that's done, you want to make sure that you clean your wood thoroughly. Don't leave any dust on there because that's going to gum up and make little divots on your surface. After your wood is all clean, you're going to take your paintbrush and dip it into your stain. You want to make sure you don't submerge the whole thing, just the tip. The stain will run up the bristles a little bit, which allows a little bit more stain in there, so you don't have to really dunk it. After that's done, you want to start in the middle of your board and do nice, even strokes. You don't want to ruffle your bristles up because that's going to make a funny looking pattern with your bristle strokes. So you start in the middle and work your way to the edges. That way you don't get a lot of runoff because you're going to do the sides in a different step. And if you try to apply it after it's run down, it's going to leave a real dark spot. You want to dip for more stain when you end up leaving a lot of streaks in your wood. You want to make sure that the stain is covering all the wood on a couple passes. If you leave little imperfections where the stain hasn't covered, it'll affect your end product. You also don't want to stop and let one section dry while you go down the other side of the board. You want to make sure that you're applying wet stain to other wet stain. Otherwise, it'll leave a real dark line where you stopped and started. You always want to run with the grain. You don't want to go against the grain because the bristles will leave new grain strokes going against it and end up crossing those old ones. After you've stained your wood, you're going to take your sponge or rag and wipe off all the excess. If you don't, it'll dry just a little tacky or gummy and a lot of dust will stick to it. So you want to get all that excess off. And this also helps cover all those imperfections in your wood where your bristles didn't hit. Also, it pulls out the different grain textures because some of the wood is harder than other parts, especially in these mineral streaks, and you want to pull that out and make it pop in the wood. If you leave that stain on there, it's going to dry more like a paint where you don't see all the different grain streaks. Following these couple steps will make sure that you have a nice looking varnish that'll last quite a while. Thank you all for watching and good luck with this project.